Have you ever wondered if we could travel through time, just like we traverse through space? This thought-provoking question has captured the minds of scientists, philosophers, and dreamers alike for centuries. It is the spark that ignites countless sci-fi stories and fuels the passion of many theoretical physicists. Time, much like the space we live in, is a dimension. We're used to thinking of our world in terms of three spatial dimensions: length, width, and height. But what if we could add another dimension to this mix, a fourth dimension, time, that we could navigate just as we do the others? This notion is not as far-fetched as it might initially seem. Many theories in physics, such as Einstein's theory of relativity, suggest that time can be bent and twisted much like the space around a massive object. But does this mean we can travel through it as we do in space? So we've established that time is a dimension, but can we really travel through it? Let's delve deeper. To understand time travel, we first need to comprehend the concept of time itself. Now, imagine time as a river. It starts at a source and flows in one direction towards an ocean. This is how we perceive time in our daily lives, constantly moving forward from the past, through the present and into the future. Yet, what if I told you that this river of time doesn't flow at the same speed everywhere? This is where Einstein's theory of relativity comes into play. According to him, time is not an absolute quantity, but something that can be affected by gravity and speed. Let's break it down. Picture yourself standing next to a clock tower. As the clock ticks, the hands move at a steady pace. Now imagine you start running. According to Einstein, if you could run at a speed close to the speed of light, the hands on the clock tower would appear to move slower. This is due to a phenomenon known as time dilation. In the realm of the cosmos, time dilation happens when you're near a massive object like a planet or a star. The gravity of these celestial bodies bends space-time, causing time to slow down. The closer you are to the source of gravity, the slower time runs. This is why astronauts on the International Space Station age a tiny bit slower than we do here on Earth. But let's push the boundaries of our imagination even further. What if you could travel at the speed of light or fall into a black hole? In theory, time would slow down so much for you that you might even travel into the future. Sounds like science fiction, right? Well, while we have no practical way to achieve such extreme conditions, the mathematical equations of Einstein's theory do suggest that it's theoretically possible. Time dilation is a fascinating concept, but does it really make time travel possible? Let's explore further in the next segment. Science fiction has often depicted time travel, but what does science itself say about it? Let's delve into the theoretical possibilities of time travel. One of the most popular theories involves wormholes, structures predicted by Einstein's theory of general relativity. Imagine a tunnel with two ends, each in separate points in space-time. One could enter one end and instantly pop out at the other end, effectively traveling vast distances in space and even time. However, wormholes are still theoretical and yet to be observed. Another theory involves black holes, these mysterious regions of space-time where gravity is so strong that nothing, not even light, can escape. Some theories suggest that passing through a black hole could lead to another time or universe, but the intense gravitational force would likely obliterate anything trying to pass through. It's a high-risk, unproven theory, to say the least. Now, let's consider the paradoxes that arise with time travel. The grandfather paradox is a classic example. Suppose you could travel back in time and accidentally prevent your grandparents from meeting. This would mean you were never born, which contradicts the fact you were able to time travel in the first place. It's a loop without a beginning or an end, challenging our understanding of cause and effect. Then there's the bootstrap paradox, where an object or information sent back in time becomes an endless, self-created loop. For instance, imagine a book you send back in time becomes the very book you later find and send back. Where did the book originate? These paradoxes pose significant challenges to the concept of time travel, suggesting it could violate fundamental principles of the universe, yet they are based on our current understanding of physics, which is always evolving. Time travel poses numerous paradoxes, so is it really possible or just a fascinating concept? We might not have a definitive answer yet, but the exploration of these theories and paradoxes continues to push the boundaries of our understanding, making the world of science an ever-exciting realm. After exploring the theories and paradoxes, where do we stand on time travel? We've ventured through the labyrinth of time, unraveled its complex layers, and stood at the precipice of its paradoxes. Let's take a moment to reflect on what we've learned. Our journey began with understanding time itself. We've seen that time is not a fixed entity but a relative concept, bending and stretching in response to gravity and velocity. This fundamental concept, born from Einstein's brilliant mind, serves as the foundation for our exploration of time travel. Next, we delved into the theoretical possibilities of time travel. We've danced with black holes and wormholes, flirted with cosmic strings, and toyed with the idea of the multiverse. These cosmic phenomena, while seemingly fantastical, are rooted in scientific theories and mathematical equations, yet they remain largely unexplored and, for now, beyond our reach. We then grappled with the paradoxes that time travel poses. The grandfather paradox, the bootstrap paradox, and others like them challenge our understanding of causality and our perception of reality. They remind us of the complexities and mysteries that time travel entails, which we are yet to fully comprehend. So, where does this leave us? Time travel, in theory, is possible. The laws of physics, as we currently understand them, do not prohibit it. But the distance between theory and reality is vast. Our current technology, our understanding of the universe, and our ability to navigate its complexities are far from sufficient to make time travel a reality. We stand on the threshold of a vast unknown, a frontier that challenges us to push the boundaries of our knowledge and technology. Time travel is not yet within our grasp, but it remains a captivating allure, a tantalizing mystery that continues to beckon us forward. Time travel remains a captivating concept, a riddle that science continues to unravel. Until our next journey through the cosmos, keep exploring, keep questioning,